Okay, so we've got our products, rather our reactants. What are our potential products? Give me one of them. Barium sulfate and sodium chloride. And what we don't know is we don't know the state information on these. We do also, again, have to have this balanced. So we would get 2 moles of sodium chloride out of this and only 1 mole of barium sulfate. Is sodium chloride soluble in water? Yeah. You've been to the beach, right? You've been to the ocean. So we know that one is soluble. What about the barium sulfate? You can use your rules to look it up. Barium sulfate is, oops, and I just wrote S there. That was ridiculous. Try aqueous. But the barium sulfide, that one is insoluble, so it's going to be a solid. I was thinking soluble, and I wrote my S. Oops. Okay, so we've done that. Now we need to do what? Yeah, gross ionic equation. The overall, the big equation that's tough to fit. So we've got the reactant side. What's going to go over on this other side? Does barium participate in a reaction? Yes. So we know that we're going to write our barium sulfate as a solid. But our sodium and chloride ions, well, they're just standing around pretty much doing nothing. Okay, so we've got our overall, or gross, ionic equation. Step 4, cancel out those spectators. So we have chloride and sodium just standing around doing nothing. We can cancel them out. Cancel out the spectator ions. And step 5 is rewriting the net ionic equation. So for that, we're just going to write Ba 2 plus aqueous plus SO4 2 minus aqueous, and that yields Ba SO4 solid. All charges balance. All atoms balance. It's balanced in every possible way. Does that make sense? One more example I want to do with you, because it's the tricky, weird example, and you'll have a few of these in the homework. Okay, how do you figure out which are the spectators? Whichever ions don't form a compound are the spectators. So if they're in the same state on both sides of the equation, they're still in aqueous solution, they're a spectator ion. Because they're just hanging out in the solution. It's like people who are hanging out in the pool, floating around in inner tubes. That's essentially what they're doing. They're not swimming. They're not doing anything. They're just watching everybody else be active. Okay, will the precipitate form if aqueous solutions of potassium nitrate and magnesium sulfate are mixed? If so, write the net ionic equation. Step 1, formulas and dissociation. Writing the dissociation equations. So we've got potassium nitrate, KNO3. We have magnesium sulfate, MgSO4. Dissociate them each in water. We got aqueous solution of potassium ions. And some nitrate ions. Dissociate that magnesium sulfate, we get Mg, oops, magnesium 2 plus ions plus some sulfate, SO4 2 minus, also in aqueous solution. Okay, step 1 done. We know that these things will dissociate into these ions. Now what? What do we do next? Yeah, we do a double displacement and we check out the solubility of any potential products. So in other words, if we take these two things in aqueous solution, so step 2, 2x replacement, check solubility. What would we get out of this? Well, we'd get K2SO4, because remember sulfate has a 2 minus, potassium is a 1 plus, that'd be K2SO4, and we'd get magnesium nitrate, Mg, NO3 2 times. Again, magnesium has a 2 plus charge, nitrate only has a 1. So we do have to balance this, of course. And it's pretty easy. We just stick a 2 out there. Okay, so we know that these are in aqueous solution. We're unsure of the state of these. Are they soluble or not? So check your solubility. What do you find? Okay, so the potassium sulfate is soluble, so it's going to be an aqueous solution. What about the magnesium nitrate? Yeah, it's also soluble. What does this mean? There is no precipitate. No precipitate forms. So at this point you get to write no reaction. And you're done. No reaction occurs. Everything is a spectator ion. There is no net ionic equation. What you end up with is just a soup of ions, and nobody is sufficiently attracted to anybody else to go pair up and form a precipitate, to form a solid. So they all stay in aqueous solution. No reaction occurs. You can't write a net ionic equation for it because they are all spectators. Every now and then you get a few of those. You just write no reaction, you move on. You only have to do 2 steps. Questions, comments, concerns? It's pretty easy. It's not hard stuff. It's just a lot of steps. So chapter review number 16 through 18 are the assignment for this, and that is all parts, and including 18 is it's a good challenging problem. It's got some additional stuff. So we will be grading, I won't be here Friday. So we're going to grade tomorrow. Grade and discuss tomorrow. And then you'll have a quiz on this on Friday. Yes, ma'am. Okay, so 16 through 18, due Thursday, 5/26, that's tomorrow. Okay, get to work.